Okay, we have we finished section about basic citation, which was in lecture 7 and 8. Okay, and we derived two equations, one for the relative motion, Z, and one for the absolute. This is the absolute equation, x over y, and Z equation. And you can put it as Z over y. And then in lecture 8, it was the vibration isolation. There will be a force transmitted due to the vibration that comes from machine or from the ground, and the force is measured or calculated as the sum of the spring and the damper force. Okay, and then we derive the transmissibility TR equal to Ft over F naught, which is equal to x over y. Okay, and you can calculate the transmissibility, or you can calculate the transmitted force. Okay, so this tutorial is about those two topics. I will skip for the time being question number 1. Start with the question number 2. Okay, in question number 1, you have to derive the equations. Well, I'll come back to it. And if we have time. Question number 2. The figure below represents a simplified diagram of a spring supported vehicle traveling over a rough road. Determine the equation of the amplitude of the weight as a function of the speed and determine the most unfavorable speed. Okay, so this is related to the example we did in basic citation, that when a car travels over a rough road, the tire will give excitation to the body of the car. Here, the model we have is the simplified model, and damping is neglected. There is only spring. Okay, so C equal to 0, or you can put zeta equal to 0. Okay, the question is to determine the equation of the amplitude of the weight, which means x. So we have here x over y equation. You can just put C equal to 0. Okay, so this will be square root of k squared. The general equation is, k squared plus c omega squared over k minus m omega squared all squared. This is the equation we derived last time, or maybe 2 lectures back. So when you put c equal to 0, you will get this equal to k over k minus m omega squared. And that would be the equation for the amplitude. You can put x on one side. So x becomes equal to k times y divided by k minus m omega squared. Now, omega, we have to put it in terms of the speed, because we have to put in terms of the given parameters. We have the v, we have k, y, and we have L. Okay, so this will be k times y divided by k minus w over g. Okay, because g, we have w, and omega is 2 pi v over L squared. So that's the equation for the amplitude. There is another question that determine the most unfavorable speed. The unfavorable speed, or the most unfavorable speed, is the speed at which the amplitude is the highest, maximum, which is in this case will occur at resonance. We can see that if V is equal to a value that makes the denominator equal to 0, that means x will be infinity. So to get the most unfavorable speed, we can sometimes call it V critical. We put k minus w over g, 2 pi, we'll call it Vc critical, over L squared equal to 0. Okay, and from here you can get Vc. Okay, so this is given in terms of, the answer is given in terms of M, but I think we should put it in terms of W because W is given. Okay, then you can find Vc, the critical speed. Okay, clear? Okay, question 3. The springs of an automobile trailer are compressed 10.16 centimeter under its weight. Find the critical speed when the trailer is traveling over a road with a profile approximated by a sine wave of amplitude 7.62 centimeter and wavelength of 14.63 meter. What will be the amplitude of vibration and the transmitted force at 64.4 kilometer per hour? Neglect damping. Assume the mass of the trailer is M equal to 1,800 kilogram. Okay, tell me what is the use of the 10.16 centimeter? Okay, you know what can we do with this value? Okay, the springs of an automobile trailer are compressed 10.16 centimeter under its weight. So this is statical deflection. Okay, and the statical deflection, you can determine the initial frequency from this value, right? So we have omega n equals square root of g over delta. Make sure that the units are consistent. So this would be 9.81 meter per second square divided by 10. Delta is 10.16 times 10 to power minus 2. Right? Always make units consistent. So this will give you radian per second. Okay, so we can use the statical deflection to find the initial frequency. Omega is given, as I said, you can find it from the velocity. This is V, and this is L. So you can find omega is equal to 2 pi V over L. So this will be 2 pi. V is 64.4. You convert it to meter per second, we divide it by 3.6. Divided by L, which is 14.63 meter. Okay, and you can get omega. Damping is neglected, and we have y equal to 7.62. You can find amplitude. Okay, amplitude will be x, as we did above. It was with undamped, it is ky divided by k minus m omega squared, right? So you can divide by k, We don't have the value of k. You can calculate the value of k if you want, if you have the mass. Okay, yes, we have the mass. So you can calculate k. Okay, but if you don't want to calculate k now, at this stage, you can divide by k. This will be y divided by 1 minus omega over omega n squared. Okay, y is 7.62 centimeter, and you can keep the same unit. So it means the answer you will get in centimeter divided by 1 minus, omega over omega n squared. Okay, you can find k because to answer the question, the transmitted force at this speed, the same speed. The transmitted force is if t, we look first of all at the free body diagram. The free body diagram, in the case of basic excitation, that the force, this is the same as this problem. Okay, the free body diagram shows that the transmitted force is the spring force only, which is kx minus y, which is z. So the transmitted force is kz. Okay, the formula sheet it will not give you all the cases of the transmitted force. It will be just one, but you should be able to know what is the other how to calculate ft. Okay, let me just share with you the formula sheet. Okay, the formula sheet, there are two pages. The second page, we have ft, vibration isolation. The equation given is the equation we derived in the class, which is kx square root of 1 plus 2 zeta omega over omega n squared. Okay, this is the equation given. But this will give, this is a guide, the formula sheet is a guide for you not to study from it. Okay, so you have to think of the type of the problem. If the problem is basic citation, then you have to change x to z. That's the only thing you have to do for basic citation. And x is, if this is direct excitation force, it means x is x the same. And if this is imbalance, also you have to find x from imbalance and then substitute here to find the transmitted force. Okay, for basic citation, you need to change x to z because the force is through the spring and the damper is the vector sum of the spring force and the damper force. Okay, so the force, when you put z equal to 0 or c equal to 0, it is going to be kz only. So it is kz square root of 1 plus 2 zeta omega over omega n squared, but we know that zeta is 0. For this problem, this becomes only kz. So I need equation for z as well, and the basic citation, as I told you, we derive two amplitudes, the relative amplitude, which was z, and the absolute amplitude, which was x. Here, for the transmitted force, I need to get z equation. Okay, so the first thing, to get ft, it is k times z, and Therefore, I need Z. Okay, Z is equal to M, not M, it was K or Y R squared, which is omega over omega n squared, divided by square root of 1 minus R squared all squared plus 2 zeta R squared, where R is equal to omega over omega n. Okay, but here we have zeta equal to 0. So you can put reduce this equation to only y r squared divided by 1 minus r squared. That will be z. And then if t equal to, substitute in here. So you need k as well because as you can see, it is kz. So we get from omega n, we get k equal to m omega n squared. Okay, so we have omega n from square root of g over delta here, and m is given is 1,800 kilogram. You can find k. If I look at, this is one way. Alternatively, okay, then you can put, after that, you can put if t equal to k times z. Okay, this is one way. Alternatively, if you look at the free body diagram, it is here k times z. This is the mass, and it's moving with velocity v over a rough road. And kz, when you use the Newton's second law, sum of forces equal to mx double dot, right? So it is minus kz equal to mx double dot. Kz is ft, as we said. So this is minus ft equal to mx double dot, right? So the magnitude of ft equal to minus, and minus becomes plus. So also it can be written, the magnitude of ft is going to be m omega square x as well. So the amplitude, the magnitude of ft is ft equal to m omega square also. So either this equation you use ft equal to kz, or you can use ft equal to m omega square x, because x double dot is equal to omega square x. That is the absolute value. Okay, or the magnitude without the minus. Okay, and you check. You have here, you don't need to find k because m is known and x is calculated. Omega is also calculated from 2 pi v over m. So you can try those two equations to see if you get the same answer. Okay, you get the idea? The transmitted force is also equal to mx double dot. The amplitude of vibration, there are 3 answers here. Okay, what will be the amplitude of vibration and the transmitted force at 64.4 kilometer per hour? I don't know what that is, meter per second here. Okay, are there 3 questions? Find the critical speed. So this is the critical speed. I didn't talk about it, but same as the question number 2. So V critical is equal to same as question number 2, 2 or 1, 2. Yeah, you can get the equation from which is L over 2 pi square root of K over M. Okay, question number 4. The mass of an automobile is 450 kilogram when empty and 1,400 kilogram when fully loaded, vibrate in a vertical direction while traveling at 90 kilometer per hour on a rough road having a sinusoidal waveform with an amplitude y equal to 0.1 meter and a period of 3.65 meter. So we have, this is N. Assuming that the automobile can be modeled as a single degree of freedom system, this is the simplified model, with stiffness 44 kilonewton per meter and damping ratio is 0.2. Determine the amplitude of vibration of the automobile, so that will be X, and the force transmitted, which is Ft, when it is empty and fully loaded. So the mass will change. When it is empty, the mass is 450 kilogram. And when it is loaded, fully loaded, it's 1,400 kilogram. So you will find X and Ft for both cases. So this is why there are two answers for the amplitude and for the force transmitted. Okay, so it will be, there is only zeta here. This is damped system, not undamped. And you will use the equation as X equal to square root of 1 plus 2 zeta r square over 1 minus r square or square plus 2 zeta r square multiplied by y. Okay, or x over y equal to this. And you will find x. Okay, what is r? R is omega over omega n. And omega n is going to change for each case. But omega is at 90 kilometer per hour is omega is 2 pi v over L. So it's not going to change, but omega n, where there will be omega n for empty case is square root of 450 over K. And this is for empty. And for fully loaded, omega n is square root of 1,000. I just switched them. K over 450. And this will be K over 1,400. Okay, so there is case number 1, case number 2. And then frequency ratio will be, for each case is going to be different. Question 5, an aircraft radio weighing 106.75 Newton is to be isolated from engine vibrations ranging in frequencies from 1,600 to 2,200 CPM. CPM, it means cycles per minute. What statical deflection must the isolators have for 85% isolation? Here the vibration is propagated to the radio. So you need to isolate the radio from the excessive vibration, which comes at frequencies from the engine of the aircraft from 1,600 to 2,200 CPM. With the given information we have is the isolation to be 85%. Isolation, how this is related to transmissibility? Isolation is equal to 1 minus transmissibility. Okay. So that TR will equal to 1 minus 0.85 is 0.15. We don't have equation for isolation. We have the equation for the transmissibility TR. But isolation is the opposite of transmissibility. Okay, the transmissibility is the amount of force transmitted ratio, the ratio of the transmitted force, okay, to disturbing force, which is F naught. The isolation is how much you isolate the transmitted force. So 85 isolation means 15% transmissibility. The graph of the transmissibility, if you go back to lecture 8, okay, this is the graph, which is x over y. I will just pick one of them. Here, assuming z equal to 0, because the question in the question there is no mention of the damping ratio. So take z equal to 0 or take c equal to 0. Okay, so we'll assume that z equal to 0. The transmissibility equation TR here is one. It's the equation of xy, right? So it is for undamped or even for anyone, even z equal to 0, it will go up and then come back. And this is at square root of 2, right? So this will be asymptotic to the 0. Now suppose this is not the frequency ratio, this is the frequency. Okay, I will assume that here is 1,600 CPM. And here is 2,200 CPM. The given range. This is the range from 1,600 to 2,200 CPM. So the frequency of excitation, which one we will take? When we come to the transmissibility TR, it's equal to, for undamped, it's equal to 1 over 1 minus, okay, we have for isolation region, we said it is going to be 1 over omega n squared minus 1. Okay, I'll just remind you of what we did last time. Okay, that TR is equal to a switch. The denominator terms are a switch for z equal to 0 to get positive value. Okay, this will be positive. And if we are in the isolation region, so we'll assume that 1,600 and or the range should be in the isolation region, not in the magnification region. Okay, and accordingly we will find the required delta. So which omega we should use? Omega n, this will reduce to, it is already in the lecture that if you want to put it in terms of delta, it is 1 over 2 pi, 1 over 2 pi f squared, delta over g. Here f is in cycles per second, hertz. minus 1. Okay, so which if we should use in the question? Okay, that will be what we have to think about. So it is 1 over 2 pi f square t over delta minus 1. Maybe delta over t, right? Let me check. Yeah, delta over t. So if we divide by 60, we divide by 60, we made f equal to in hertz. Okay, so let's say this is f1 and this is f2. Which one I should use in the range? Or someone in the, or some frequency in the middle? Okay, f1 will correspond to TR that is greater than that correspond to the second f2. So the transmissibility at f1 is higher than the transmissibility at f2. So if you design the isolator, which means finding delta, which is at the end you will find k if you want. If you design it at f2, it means the transmissibility at f1 will be higher than the required, which is 15%. So the 15%, if you make it here, it means this will be higher. Let's say maybe 0.2. But it is higher, يعني. It is going to be greater than 0.15. So at f1, you know, this is the question. If you put here f2, then the transmissibility will be at f1 will be greater than square root of will be greater than 0.15. So in the range, the transmissibility will be higher except at f2, which is not the required case. So what you can do is make 0.15 here at f1, and then at f2 it will be less than 0.15, right? This will be less than 0.15. Let's say maybe 0.1. Okay, so it's going to be less than. So if you are given a range, you use the beginning of the range to guarantee that in the rest of the range, the value of TR will be less, and that will give you more isolation. So isolation will be 85% here, and here this will be less than 85%, greater than 85%. You will have more isolation. Okay, in terms of the transmissibility is 15 here. This will be less than 15%. If you choose at F1, you put the transmissibility equal to 15%. So you don't choose, this is rejected. Okay, you use F1. Okay, the beginning of the range. This will guarantee that the transmissibility is less than 15% within the range. Okay, and the transmissibility equal to 0.15. Okay, the only unknown here is delta. Delta looks like D here. it is delta. Okay, the only unknown is delta. If one just make sure it is in hertz, cycles per second, not cycles per minute, so that the units will be consistent. Okay. Question number 6, an electric motor of mass 68 kilogram is mounted on an isolator block of mass 1200 kilogram. Okay, so this is 1200 kilogram and the mass, yeah.
الساعة 9:10 الحين.
اوكي على ساعتي باقي دقيقة.
ما تخلصت دكتور؟
نخلص 9 اليوم. 9 نخلص صح. أنا فكر 9 10 نخلص. Okay, so I'm going to stop here. مشكور حسن. يلا مع السلامة.
دكتور عندي سؤال بخصوص الكويز.